Welcome to Garden Chatter. We connect gardeners, bloggers, and experts so we can all grow and learn. I'm really excited about tonight. We have an author that's going to share some exciting information and her book. And my name is Adam Cortell, and my co-host Brenda and I will be bringing you through this Garden Chatter. Brenda, how can people join in on the conversation tonight? We've had a little bit of trouble with that. Why don't you go ahead and explain it?
Sure. I'll try to keep it really simple because it really is simple. And so if you're watching us on the Google event page, you're going to take your cursor right on top of the video that you're watching right now. Go right up to that right-hand corner. You'll see a grid. Click on the grid, and then a Q&A will pop down, and shout out and say hi to us on there. Also, I'm watching the Twitter feed tonight, so if you have a question or you want to say hi, feel free to communicate with us on the hashtag Garden Chatter. Adam?
All right. Well, tonight we have our guest, Kristin Ohlson, and Kristin is a writer that's written several different books and a couple diverse topics. So she's going to be telling us tonight about her book, The Soil Will Save Us. So, Kristin, how are you doing tonight?
I'm great.
Very good.
Never done a Google Hangout in this kind of format before, so I'm interested too in how this is going to work.
Yeah, you said that you had done like a monthly hangout with some other authors, so you'd had some experience with it. That's great. Well, I was wondering maybe if you could just go ahead and give us a little bit of a rundown on some of your writing history, and how did you lead up to writing a book about soil?
Well, I've sort of had a writing career for the last couple of decades that I've been a general interest freelance writer, so that means I've written about, things, largely about things that have interested me, sometimes things that interest different editors that I've worked with. So I've written about all kinds of things. I've written about feminist philanthropy and fish bioengineered to glow in the presence of pollutants, and bluebird restoration efforts, and archaeology, and brain science, and I've written about really a lot of things. But I kind of always wanted to write about gardening and nature, and I just never quite found the right idea that worked for me and for an editor. And then there was a chef in Cleveland that I had written about for Gourmet magazine, and he was one of those early pioneers who started looking for local farms to provide produce for his restaurant. And anyway, just a really interesting man, and he was the one who first told me about something called carbon farming. All these different farmers around the world who were talking about agriculture that built up the carbon in the soil instead of depleting it, and that's what led me to this subject.
So maybe you could give us a little bit of an overview of your book, The Soil Will Save Us. Just what are some of the highlights or kind of the gist of it?
Well, the book talks about this whole idea of addressing, the biggest challenge, the biggest environmental challenge that humans have right now, which is climate change, which is that terrible buildup of greenhouse gases in the atmosphere, one of the primary gases being carbon. And I start off in the book talking to a scientist, a soil scientist, who early on made a connection, back in the 80s, made a connection between the way lands were being degraded by bad farming and the carbon that was lost in those soils, some of which was washing down into streams, but a lot of it which was volatilizing and going up into the atmosphere. So he early on made a connection between the carbon that land was losing and the carbon that was going up into the atmosphere. And he started talking about how can we do an agriculture, how can we manage our lands that instead of making the land sicker, makes it healthier. And so the book really takes off from there, talking to scientists who are studying how different land practices change the soil, but the most exciting part for me was talking to farmers and to a certain extent gardeners who are figuring out how to work with nature instead of violating nature all the time. Basically the agriculture that we've had for many, many years, I'm talking thousands of years, has been one that's kind of violated nature, and never so much as in this modern era of industrial agriculture. But what's really important, I think, for our health, for the long-term health of our planet, is if we develop agriculture that stops violating nature and works with nature's laws, and that creates a healthier food, a healthier environment. And it can be done. There are farmers who are doing it.
Yeah, absolutely. I was thinking,
we've got a couple of people who are saying hi to you tonight, Kristin. We've got Javon's on, and Aaron. Aaron's out your way in Seattle, and I think Javon, she's near Washington, D.C., and then we got Bean and B on. So thanks for joining us tonight, guys.
Yeah,
hello.
And Alexis, Bean and B is Alexis. She's down in Texas, I believe. Get that right? I think so. Anyway.
All different soils. That's awesome.
Yeah. So I was just wondering, how is the carbon? I mean, the carbon is mostly bound up in the soil, in the soil food web and humus and just all the organic matter. Is that correct?
Yeah, I mean, the main way that the most important way that the carbon gets in the soil is through the roots of plants. So plants, are the most amazing technology that has ever been invented. Plants do this amazing thing where they use energy from the sun, and they grab carbon dioxide out of the air, and they convert that carbon dioxide into a carbon fuel for, to grow their stems and their trunks and their leaves and their fruits and their roots. But plants share, they send around 40% and sometimes a lot more. They send, 40% of that carbon fuel down to their roots, and there it's leaked out. They share it through their roots with the microorganisms that live in the soil. And those microorganisms have been in the soil for billions of years. Plants have been in the soil for millions of years. They have this trading relationship. So plants are actually sharing some of that energy source with the soil microorganisms. Soil microorganisms are taking that, and in return, they are delivering to the plants nutrients that they have liberated from rock and sand and silt and clay. So it's this trading partnership that's been going on for millions and millions and millions of years, and that's how carbon builds up in the soil. Those soil microorganisms take that carbon fuel from the plants, and they grow with it, and and they eat each other, and they that carbon fuel keeps getting condensed and concentrated in the soil through that kind of microbe eat microbe world down there. They also create a carbon glue to make habitat down in the soil. So they're taking they're making a carbon glue. They're gluing together a piece of silt and a tiny little piece of a leaf and a piece of sand. They're making these little habitats in the soil, really cementing that, and by doing that, they're cementing that carbon into the soil, and they're also creating structure in the soil. So I'd love to look. I think that we all have such a wrong idea about what the ground is like when we walk over it. We think of it as solid ground, like it's just like it's like rock underneath us, and it's actually extremely porous. So that when they are using that carbon glue to create habitat, it's kind of like making millions and millions and millions of little cups and saucers in the soil to hold water, and that holds gases in the soil. So really, we're walking over something that's just bubbled with these little structures that the soil microorganisms make. But anyway, that's how all that carbon gets in the soil.
Yeah, I've been super interested in soil biology, and I'm actually reading right now, let's see, Teeming with Nutrients, and then I'm going to read Teeming with Microbes. And I took one of Elaine Ingham's like a 2-day workshop over the summer on the soil food web, and so I just really got excited about that. In fact, I want to get a microscope so I can start looking at my own soil and compost. Well, you got to travel around a bit for this book, and I was wondering, I was really interested. I read your book, and the part where you went to, was it Southern Africa? Was it Zimbabwe or South Africa?
Zimbabwe, yeah.
Yeah, Zimbabwe. Could you tell us a little bit about some of the transformation that you saw going on down there? Because that was pretty neat. I mean, it was a couple thousand acres that, you know, what was his name? Is it Savory?
Alan Savory. He's been a really pioneering scientist and land use manager. He years ago started to realize that you know, people always talk about lands and it's true, lands being degraded by grazing animals, by animal husbandry, and he realized after much trial and error on the land that it wasn't the presence of animals that was ruining the lands. It was the way they were being grazed, and it was the way that humans had changed the patterns of how animals moved over the land. So before humans, you know, there were these vast herds of herbivores that would move over the lands. You know, we had buffalo in the United States moving over these vast prairies. But there was a certain way that those herds always behaved on the land because there were predators. There were predators all around, so they had to do certain things to stay safe. So one of the things was that they stayed clumped together. They didn't spread out all over the place. They didn't linger in places for a long time. You know, one of the problems with animals grazing, the way that we have tended to do it since we domesticated them, is that they can just stay in one spot and eat the grass and take it all the way down to the roots and pull the roots up and just kill that plant there. Well, animals in their natural habitat, when there are predators around, they don't ever stay anywhere long enough to do that. They're kept moving over the land. They're kept bunching up together. So there's that constant movement over the land where the animals are actually beneficial to the land. Their hooves are you know, breaking up the soil a little. They're pushing grasses down into the soil where the soil microorganisms can eat them. They're dumping their urine and dung on the ground, which is good for the land. But when humans changed that, they would stay in one spot and just, you know, kill the grasses. So one of the things that Alan Savory realized was that he came up with this method called holistic grazing, or this way of thinking about grazing called holistic grazing. And basically, it shows people who have animals how to move those animals over the land, whether they're using herders like he does in Zimbabwe, or farmers here, when they have animals and they're using holistic grazing, they often have these series of electric fences that they can just sort of move around. You know, they just move a wire around and move the animals from one small paddock to another. But when people are doing holistic grazing now, they're sort of trying to carry out that same idea. They're keeping the animals sort of clustered in smaller areas instead of just letting them spread out for a long period of time. So they're moving them from one small area to another so that the grasses are always being eaten, and that kind of stimulates growth. And the animals are having a beneficial impact on the land, but they're never there long enough to kill the grasses. So they move them on so that the grasses can have a growth cycle. So it's actually really good for the land. When I was in Zimbabwe, and when I was in North Dakota visiting a farmer who uses holistic grazing, you can see the lands where the animals are grazed compared to the lands where animals are not grazed. And the areas where they're grazed with holistic grazing are actually healthier.
Yeah, I found it interesting that down in Zimbabwe that he had, you know, several hundred cows or whatever number, and as the soil improved and there was more and more vegetation, he actually needed more cows on the same acreage to have enough to really move in and trample down and eat an area, and then to move them on. So he was actually ended up running more livestock than he had started with.
Yes, he was inviting, villagers to add their herds in there to be managed in this way too, just because he wanted more animal impact on the land.
Yeah, so I think it's. Well, go ahead.
So I haven't read this book yet. I'm sorry, but I definitely want to because this sounds really interesting. So all these crazy going in my head with what you're talking about. I warned you before we came on, Kristin. I'm just an everyday gardener. So if you have the cattle and you have the herds, so they're grazing in one location, and then what do they do? Move them over, and then they grow their food where they were, and then just kind of rotating crops, kind of?
No, they don't do that. These are pasture lands, so they're just moving them on so that the way they're moving them keeps those pastures really healthy and growing. So the grasses will be invigorated by having the cattle be there for these short periods of time and move on.
Okay.
When you were in North Dakota, did they do, a little bit like Brenda was saying, grow a cover crop and then have, they probably do that some, right, where they move the cattle onto the cover crop?
Yeah, that's what, so the farmer that was actually, I did go to Zimbabwe and I did go to Australia, and it was really exciting to go those places, but honestly, I think my favorite place of everywhere that I went was North Dakota, to see these farmers in North Dakota and these really innovative, thoughtful farmers who are thinking all the time about the soil. So I primarily visited this one farmer there named Gabe Brown, who over the last 15 or so years has gone from being a completely conventional commodity corn and wheat farmer to a farmer who kind of just uses what he knows of natural processes to run his farm. So he no longer uses any chemical fertilizer or any fertilizer. He no longer uses pesticide. He no longer uses fungicide. He no longer plows. He uses a no-till drill. He uses a little bit of herbicide every couple of years for some persistent weed things if they crop up, but he doesn't use them. He doesn't use herbicides the way that most of those farmers in that area do. But yeah, he has, so the way I just love this, the way he prepares a field to be planted. So say he gets a new piece of land and it's been in conventional agriculture and he wants it to be in good shape for his kind of agriculture. It usually takes, so people usually estimate that it takes about 3 years if something has been farmed conventionally. And what happens when something is farmed conventionally is that basically all that life that's in the soil, that microscopic life that's in the soil, it just kind of gets beaten out. So healthy soil, there's something like, although I think the number keeps changing all the time, the more scientists look, but it's something like 6 billion microorganisms per teaspoon of soil. It's just incredible life that's in the soil, and really that's the life. Those are the life forms that built the earth. So in a conventional, industrial chemical agriculture setting, everything that happens in that system kind of kills off that life in the soil and makes it very difficult. It makes it almost impossible for the plants to have that reciprocal relationship with the microorganisms in the soil. So it takes about 3 years of going to more regenerative agriculture, regenerative land management for those soil populations to come back. So anyway, what he does when he gets a new piece of land is that he plants it with cover crops, and cover crops are something that farmers plant over fallow land, and it's not a crop that they're going to take to market. It's just a crop that's there to protect the soil. But because of the way he understands soil, so he understands very much that relationship between plants that are feeding the soil microorganisms through their roots and the soil microorganisms that are bringing minerals and nutrients to the plants. Because he understands that, he knows that all those the more roots that he can have growing into the ground, and the more diverse plant life providing those root exudates to the microorganisms of the ground, that the healthier that soil is going to be, the quicker that those populations of soil microorganisms are going to rebound. So when he gets a new field, he plants it with cover crops, and not just, like lots of farmers will, not nearly enough farmers use cover crops. I think it's probably around 2 or 3%. But when they do, they're often just using one cover crop or two, maybe 2 or 3 combinations of plants. And he realized that, he really wanted, the utmost diversity that he could have. In the prairie near where he farms, there's like 140 different kinds of plants in a square foot of prairie. So, he wants to like mimic that natural diversity. So he plants cover crops like with 25 different varieties, 30 different varieties, and they go all the way from huge sunflowers that have roots going way, way down to radishes and everything in between, because he's trying to mimic. So if you think about a forest with all the different levels of vegetation there are in a forest, there's trees, and then there's shorter trees, and then there's shrubby things, and there's tall perennials, and and then there's just tiny little things growing on the forest floor. So he's trying to mimic that incredible diversity of different kinds of plants and different sizes of plants, because the kind of canopy that there is above ground is somewhat replicated below ground with the root structures. Some of those plants have very, very deep roots. Some of them have shallower roots. And anyway, that's how he's getting a piece of new ground into good shape. All those plants are feeding that carbon fuel to those soil microorganisms and building up those communities of soil microorganisms. The soil microorganisms are then building carbon in the soil, and they're building structure in the soil, and that structure in the soil, all those cups and saucers, that means that when it rains, that water is not going to run off. It's going to get sucked into the ground and held there. So he does that, and so those cover crops will grow for 2 or 3 months, and then he brings in his cattle. The cattle mow it all down. They eat it, they trample it. I think he said he wants them to eat 40% of it and trample the rest of it, because he wants those soil microorganisms to have plenty of things to chew on right up there at the top of the soil. So that's how he gets a piece of new land ready for his crops. He grows those cover crops. Cows come in and stomp it down and eat it and leave their dung and leave their urine. He does that for a couple of years, and then it's ready for planting.
That is pretty cool.
Yeah.
So I'm wondering, Brenda, do you have any questions or comments on any of that?
No, I'm enjoying this. I'm just taking it all in. Wow.
Taking it in.
Soil just doesn't get enough credit. It really doesn't.
It doesn't get enough credit. It is just like the most interesting. I think that we're very curious humans. We've learned a lot about the world that's above the soil line. The world below the soil line has been sort of a mystery and sort of opaque to us. And I think it's really just in the last couple of decades that scientists have had the tools and have had the interest to really study what's going on underground and to try to figure out, 6 billion microorganisms in a teaspoon of soil. Well, what are they doing there? What do they do with each other? What do they do with the plants? What do they have to do with the health of everything above ground? And it's a pretty staggeringly huge connection, and it's really just one that we're starting to understand.
Maybe Adam, can you help me with? We have a question from Javon. She's asking, do they need more land to do this? I'm assuming maybe she's trying to understand how much land you need to do the practice you're talking about.
No, I don't really think that they do. It's possible that they need less land. I know that there's often a question put to organic agriculture. Well, maybe you might make better food, and maybe it won't ruin landscapes quite as much as regular farming does, or industrial farming does, but are you going to need more land to create the same amount of food? So this farmer that I profile in my book from North Dakota, his name is Gabe Brown. He produces steadily more food than the county average where he is. So there will be a couple of farmers who will have higher yields than he will on some years, because they've put in a big burst of fertilizer, and they'll get results from that for a while. But he steadily, he doesn't have big high years and he doesn't have way down years, but he steadily, no matter what the weather is doing, has yields that are well above the county average. And the thing I think that's always also really important to notice about his what he shows can be done is that not only does he get more yields than the county average, but he also pays a third to a half to get those yields. So because he's not using all those chemicals, he is investing far less in his farming. So he's actually making a much bigger profit than his neighbors because his costs are so low. And I think also one of the things that goes on a lot on regenerative farms is that they're stacking enterprises. So I think when he started out, and as I said, he started out as a conventional farmer. So he was just starting out with corn and wheat and I think oats. But he has since then really stacked enterprises. So he's got a lot of things going on. He's got a lot of different things that produce food and income going on the same land. So he added chickens and he added sheep and he added all these other things that move around on the land, and so he's doing really well, both in terms of how much food he produces and how much income he produces.
That's great. Someone else asked on the Hangout stream here, what is resource for these plants or the plant information? And they're really excited about the technique, and they want to know, does he then bring in natives? Does that make sense?
Native plants?
I'm guessing native plants. I know we need more characters. Twitter, right?
I'm not sure. I don't really think so. You mean when he's doing the cover crop planting? I think I'm not really sure about that. I'm not sure about that. He really encourages. Any kind of habitat that's growing there in the area to flourish, and a lot of what's I don't think I'll have to ask him that. That's not a question I've asked. I know that in the pastures where he's doing the holistic grazing of the animals, that that the land has gotten so much healthier that a lot of natives that hadn't been seen in a while are now flourishing again there. So they're seeing these pasture lands that used to be just prairie. And are now pasture land, but they're seeing a lot of native plants come back in those areas, but I don't know that he's planting them himself.
Okay.
Seeds in the ground for an awfully long time.
So Bean and B asked a question, this is a little more, it's easier. Does water quality improve as the soil improves?
Oh, absolutely. Yeah, that's one of the things that the thing that's so great about this method of farming, which could be, I don't think most of the farmers that are doing it they didn't start doing it because they wanted to reverse global warming. I think the buildup of, they're taking carbon out of the air with all these plants and with this healthy land, and it's going into this healthy soil. So they are contributing to the pull down of atmospheric carbon, and the pull down and putting that in. But that's not where that's not where they're doing this. They're doing this because they've found that they can be more successful and have better lives. I think a lot of farmers are not really pleased to be in the position of applying these chemicals that, you know, sometimes make them very sick. But the thing that's so great about this approach to farming, where you're really trying to farm with the laws of nature and respect the laws of nature and help build healthy soil, is that it's good for so many things. It's good for water quality. You know, that when the soil. So one of the things that's happened on Gabe Brown's land is when I talked about those cups and saucers, you know, that the soil microorganisms are using that carbon fuel to make a carbon glue, to make habitat in the soil. So all these tiny little holes going way down in the soil, is that soil sucks in water and holds it there, and it doesn't go running off. That when you get a big rain, it doesn't go running off and run into a stream. So Gabe Brown had a soil infiltration test done on his land, I think about 15 years ago, before he had started doing all this regenerative ag stuff. And at that point, his land, if it rained, so only a half an inch of water would infiltrate the soil in an hour, which is pretty crummy. At this point, 8 inches in an hour are infiltrated. So when you have land that can take in water like that, you know, it's not just sitting there for the plants, although it does stay in there for the plants for quite a while. It's also seeping down, going down into groundwater, and it's being purified as it passes through the soil. So that water that's soaking through the soil and being purified by the soil, and you know, soil microorganisms, they're greedy little things, and they eat oil. They eat all sorts of impurities that go into the soil. So yeah, they're cleaning that water as it percolates down through the soil. But so that kind of land, when you have land that's that healthy, it's good for erosion, it's good for water quality, it's good for air quality, because the soil is staying together instead of blowing away. It's good for, you name it. It's just good. There are just no downsides to this kind of agriculture.
Right.
So I'm wondering, so we have this technique that improves soil quality. It removes carbon from the atmosphere. It grows more food, more livestock. You save money because you don't apply pesticides and have to buy GMO seeds or anything like that. So here's the big question, though. Why is there not more of this going on? What are some of the barriers to farmers getting into this? Why is it just a few spots? What's the barrier?
It is spreading more and more, and there are just these conferences all over the country going on of farmers talking about this kind of stuff. And Gabe Brown himself, I mean, he must have thousands of visitors coming to his farm every year, some from around the world, looking to study what it is that he's doing there. Not only other farmers coming there, but scientists coming there to study, like, why is it that he doesn't have pest problems? You know, he doesn't use pesticide. Well, how come his crops aren't being eaten up by pests? The answer is that he has such diverse plant life there that it's attracting predator insect populations that are killing off his crop pests. I think that that's a really complicated answer, and I probably can't answer it all myself. Maybe
the quick overview version.
It's a question about why do people change and how do people change. There was some psychological study that I saw not long ago that was talking about the barriers from farmers making that transition from conventional to organic agriculture, and they were saying it was sort of an ideological barrier and not believing that it's but I mean, here's what I think. I think that we have this industrial structure that's grown up around farming over the last 60 years. It has taken over our universities. Our land-grant colleges receive the bulk of their funding now from private industry, not from government. And, that kind of funding for the science that goes on in our land-grant colleges, that the funding that's coming in is pushing them to study, is pushing them to to conduct studies that kind of reinforce that industrial model. So I think it's real. You know, there's a lot of sales pressure that's put on farmers. There's a lot of social pressure on farmers. You know, I think in a lot of those farming communities, the farmer's brother-in-law or sister-in-law is working for the big chemical company distribution network there, and there are all these pressures on farmers to go that chemical route. And I think also necessarily farmers are rather risk averse. You know, they have they have their whole income and their whole farm tied up in this crop out there, and they're not eager to make a change if they don't have to. And I think that the thing around, you know, one of the things that's been really clear to me in talking to some of these pioneers who are changing to this kind of regenerative agriculture is that they either were young and went into farming with a completely different mindset. So they're either in their 20s and 30s and went in thinking, I'm gonna save the world with my agriculture. You know, I'm going to make clean food. I'm going to respect the land. And they went in from that point of view. But some of these people who are in their 40s, 50s, 60s, even 70s, they didn't go into agriculture in that way, and they had sort of been trained by the ag colleges and agricultural extension services and all the other infrastructure of industrial farming. They have been trained to go in this chemically intense, machine intense, get bigger or go under mindset, and it's difficult for them to make a change. And somebody like Gabe Brown, I mean, he made the change because he was failing with conventional agriculture. He you know, he's a product of a land-grant college. You know, he went to ag school. When he went into farming, you know, he was going by the industrial ag playbook, you know, of spraying and tilling and spraying and fertilizing and the you know, that all that stuff. It's like a cookbook, you know, of things that you're supposed to do at different points. And he ran into 4 years of weather anomaly, so late hail, drought, you know, heavy rain. You know, 1 year after it, so for 4 years in a row, his crops were killed by weather anomalies because the land is so, you know, when the land is in that kind of system, it's just not resilient at all. It's you know, if the land has been in conventional agriculture all that time, it won't infiltrate 8 inches of water in an hour and hold that water in the soil for a long time. It's, you know, when it rains, it'll hit this degraded soil and then just run off into a stream. So he found that his land was so, it lacked resilience, and he was in danger of going under. So he had to stop. He had to stop going by the playbook of chemical agriculture because he couldn't afford the chemicals anymore. So he stopped with all the chemicals just because he couldn't afford them, and he didn't even want to take his combine and his machinery out into the fields because he didn't want to spend the money on the fuel. So that's when he started having his cows go in and just mow down these ruined crops. So he went no-till. He would send his cows in to get rid of all the crop residue that was there. He started going into cover crops just to keep his soil from blowing away. And he realized after a couple of years that his land was growing healthier and that it was growing more resilient, and he decided never to go back to the chemical agriculture. But I think for a lot of farmers, that's what it takes. You know, they're all of a sudden they realize that they cannot go on with that chemical agriculture playbook, that it's not serving them. It's not serving them, especially in a time when the weather is so unpredictable. You know, you really need resilient land to farm now when the rains don't come when they used to, or when they come, you know, with triple force. You know, you really need the land to be extremely resilient to be able to farm it with those weather anomalies.
Yeah, and it takes a few years to make that transition. I mean, you can't just go. I mean, your soil needs to get built up So in that time, you have to be transitioning from conventional to that system. I'm wondering, we probably are running low on time. I was wondering if we could revisit the idea of sequestering carbon from the atmosphere into the soil. And you, towards the end of your book, you mentioned some scientists down in New Mexico that were doing some experiments with compost and growing peppers. And they came up with some calculations on how much of the cropland in the world might need to be converted to a really intensive soil building regime to reduce carbon. Do you want to touch on that? Like, what would need to happen to start to mitigate some of the climate change and the carbon dioxide that we've built up in the atmosphere?
Yeah, well, that's the scientist David Johnson down at the University of New Mexico, and yeah, he started doing these. He started making this really great compost that's very. So most compost, the sort of the two main microorganisms, the two main forms of life in the soil that people talk a lot about when they talk about compost are bacteria and fungi, and most of us when we make compost, it tends to be more bacterial because we're turning the piles. And anyway, he decided he wanted to make a compost that was more fungal. Anyway, so he started these static piles. And the way that he gets oxygen inside the piles to keep them from getting too hot is sort of with pipes running in there to get oxygen. Anyway, he had made this like super compost and was finding that when he used it, he was having tremendous results with the plants, but also just seeing this tremendous buildup of carbon in the soil. And he has continued doing testing in other ways of building up carbon in the soil, and now I think that in his plots now he's really focusing on continuous planting. So he'll plant and things will grow, and as soon as they start to die down, he plants things right in there among the residue, and so he constantly has roots going in there. Roots that are going in there and pumping those plant exudates down to the soil microorganisms. Again, that whole that trading system that's been going on for millions of years. And anyway, so what he was seeing in his test plots was that the amount of carbon that was building up in the soil was so incredible that he calculated that if only, and I think he's changed this calculation, the last slide I saw from him said 14%. So if only, but what I said in my book was that if only 11% of the world's croplands were building up carbon in this way, sort of using these methods, but there are many methods that will build up carbon in the soil. Really good compost helps, and continuous planting, no-till, continuous planting. All these, I often see I have my Google alert set for different kinds of different things, and soil carbon is one. And so I often get these scientific papers that say, well, no-till agriculture, it does this, but not this, and all these different parts of this, and it's all part of a system. So somebody can't do just one of those things. They have to do what Gabe Brown does and be doing all of these things, because all of these things together are mimicking what goes on in nature. But anyway, so David Johnson was saying that if 11% of the world's cropland, and he pointed out that 11% of the world's cropland is typically not even in use every year, but that if 11% of the world's cropland were set aside and for some of these intensive carbon building techniques, that alone would offset all of our annual emissions of carbon dioxide. So it's pretty staggering, some of these, and again, that's still a model, and that's still, it hasn't been done yet, so it's not something that's proved to work. But for me, every time I hear people who are concerned about the climate talking about the urgency of cutting back on our emissions, that's certainly true. I mean, we certainly do need to cut back on our fossil fuel emissions. But unless they're talking about this other side of the equation, which is this vast technology, meaning plants and photosynthesis, this vast apparatus that exists on the earth and will for free remove carbon dioxide from the air and put it safely in the soil where it, makes our food better and makes our land better and makes our water cleaner. Unless somebody is talking about that side of the equation, I feel like they're just missing the greatest opportunity we've got.
Yeah, I totally agree. I mean, the implications are very exciting, and it makes me wonder, just how much also like home gardeners can do if around the country, around the world, everyone's building up, their soil in their backyard and just trying to really intensely get things growing. It could make an impact.
Oh, absolutely.
Yeah,
absolutely. People everywhere have control over some land, whether it's a little bit of land in their yard or if it's the park down the street. We should be trying to make all of those areas carbon sinks and regenerative spots, and that's what I do in my yard. I'm just trying all the time. I'm always thinking, what would Gabe Brown do here? I'm not going to bring in cows. But I can, really try to have a lot of diverse plants there, and I can have every single inch of ground with something growing in it. I could do a lot of things.
Yeah, I'm thinking not cows, but chickens. Ladies, get ready. You hens, you're going to have to, I'll have them all sectioned out in different little areas of the yard.
I like that idea.
Well, we'll probably need to wrap it up here. I just want to thank you so much, Kristin, for joining us. This has just really been a lot of fun hearing about all this. Bren, where can we find, we know where we can find Kristin. Where can we find our next Garden Chatter?
I would like to invite everybody to follow Adam Kertel or me, Brenda Haas, on the Google+. Just click on there and you'll get the updates when you follow us on Google+. And of course, find Kristin website. So easy, KristinOhlson.com, right?
Yes. I mean, I spell my name weirdly, but yes.
I hope hope we can ask you some more questions, because we had quite a few coming through on Twitter from a lot of the home gardeners like myself. So it'd be great if we could continue the conversation either on Google or maybe on the Twitter. I know you're pretty active on there as well. Thank you.
All right.
Thank you.
Yep. Thank you. We'll wrap with that.
Okay.